Well, I think it's a good point now to talk about the way computer science is taught. You're involved in that particular industry, if you like, teaching up-and-coming pupils about computer science and mathematics. What are your own thoughts about how computer science and IT is taught in schools and colleges at the moment? And do you see a trend, a positive trend, or is it getting worse? Or what's your own?
No, things are really, really positive. It's true I work in the university and teach university level computer science, but I've also done work teaching computer science CPD to school teachers. I got heavily involved with computing at schools and the BCS Academy. And I've been working locally in Berkshire to train teachers and train the trainers who train teachers, working with the Institute of Education at Reading University. So together with a colleague, Dr. Jota Dimitriadi, we've delivered CPD to entire local councils and their primary schools. The teaching of computer science, well, it used to be IT. IT literacy is still very, very important. People have to know how to use computers. But it's very valuable to know more. It's valuable to know the theory and science behind it, so that you can make better computer programs and so that you can do better human systems. You can analyze a problem and arrange people to work together to solve that problem, make businesses more efficient, even if it's not computer controlled. So the ideas of algorithmic thinking, problem solving, problem decomposition, testing a solution are all incredibly valuable in everyday life, regardless of whether or not you can program. Of course, programming is important. That's a skill like being able to read and write. I think everybody should be able to program at some level. And writing your own programs gives you confidence. You can model the world and test things. I would love to see artificial intelligence taught in schools because it's fun. You can do graphic arts, you can do music, you can talk to the machine, you can write programs that will take questions in English and reply in French or German or Chinese or whatever languages you're learning. You can make computing, artificial intelligence, relevant to pupils and up the game. Already we're seeing that the primary schools are doing tremendous work, and the secondary schools are not quite ready for it. The primary kids know so much, the secondary schools need to adapt and take them on. And then of course my job as a university lecturer will get a whole lot harder, that I have to adapt and take people yet further.
So what's your thought, for example, on the Raspberry Pi, which has recently come?
It's a brilliant, brilliant little device. I love the architecture. Great thing to use. Good on you guys.
Now,
so what I particularly like about that, you get this little box, and it's an entire computer, and you can see it, and you can be told and learn what all the little components are, and you can play with them and plug stuff in and try stuff out. So it takes the mystery away.
Yeah, I've seen some nice practical applications of youngsters creating little mini games, which are sort of learning games, which are very, very effective and encourage them to learn more about computing, which is...
Now, learning games is really quite an interesting opportunity. Kids engage with games, they love to play games. When they're playing a game, you could record, providing you've got permission, how they're interacting, how they're learning, and put that into the cloud. Store all of that data for all of the kids all over the world who are playing that game, different cultures, different languages, whatever it is, and then data mine that repository of stuff to find out if there are teaching strategies that work well with particular kinds of pupils, boys, girls, English-speaking cultures, French-speaking, German, whatever it is. Brilliant opportunity to leverage ICT to allow more educational research in much broader scope and much more detail. If you data mine the stuff and get a hypothesis about how the game is working or how the learning is going on, you could change the game and download it to different groups of people running a blind test, doubly blind if you want. You could do completely valid experimental research by exploiting the cloud. So, games, brilliant.
You mentioned about boys and girls there. It's interesting that BCS is very much trying to get more women involved in IT. Why is it do you think that not as many girls as boys take up computer sciences? Does it still have that kind of geeky, nerdy reputation, or do you think that's changing now? I mean, what are your own thoughts about that?
Well, historically, we know the answer. When computing started off, about 40% was women, 60% male. So it's always been male dominated. As soon as computers went into schools, the proportion of women plummeted down to about 5%. It's now risen to about 10%. So it was things going on in schools that changed the take-up of computing. And there are two sorts of things to say about this. One is that human beings really do seem to be pre-programmed to develop gender stereotypes. And that's probably adaptive and useful. Second thing is there may be some peer pressure going on, some bullying, who knows what. But computing is tremendously accessible to women and is highly paid. It would be great to see more involvement of women. In fact, I work with BCS Women. I'm organising the Lovelace Colloquium at Reading this coming year, 2014. And that's aimed at women who are university level students of computing, an opportunity to show off their research, their commercial projects, to speak to motivational women who've made it in technology. I'm still looking for a few women speakers, by the way.
That's good news. I'm just wondering if you think the government should be doing more to encourage women into IT and girls to take up IT in schools and earlier on in their education, or do you think it's just, like you've mentioned there, about peer pressure and about preconceptions of what they're going to be taught?
I think it's very difficult for governments to change society. What they can do, politicians are famous and influential. They can speak about the opportunities. If there were female technologists in Parliament, it would be great to have them speak. Love to invite you to the Lovelace Colloquium. It comes from that kind of peer pressure, and I think it comes bottom up as well. BCS Women is doing tremendous work organising themselves from the grassroots up, pushing out technology and creating a space where women can get together to talk about technology. I actually got involved in another BCS Women meeting at Microsoft, as it happens. And there was a big group of women there, sort of 60, 80 women, and I was the only man in the room. And it felt really, really weird to be the minority of one. So I appreciate the feelings women must have being isolated in a largely male community. It is really, really weird having the boot on the other foot.
Of course, there aren't that many female role models within that area of research. I mean, there are a few, but I'm just wondering who your own role models were. Why did you get into this sector?
Well, first of all, I think there are plenty of women doing brilliant work, and if they would shout about it a bit more, that would be good. There really are plenty of women leading the science of computing in all sorts of areas. My own role was, at a very, very early age, I wanted to get involved in science. Maybe about the age of 7 or 8, I knew I wanted to be a scientist. And I read a lot of history of science, the famous scientists, how they achieved their work, how they did the paradigm-breaking research. There's a great advantage to reading history of science that in the beginning, science was quite small and easy to understand in every single field. So So if you read the history of, I don't know, complex functions or the history of worms, then it's very small. And you can understand the whole thing. You can see how it fits together. And you can see how the scientists of the time came to their ideas and developed them. The other thing you can do is strip away all the explanations that have gone on afterwards that are supposed to make it easier and see what the original people really said. So, for example, Jacobi, writing in the 18th century, does an algorithm for liberating eigensystems. Terribly technical. You go back and read his original paper and it works for division by zero. The algorithm works. Every single implementation that's around today checks for a division by zero and does something special if it occurs. It doesn't need to. Every single algorithm for solving that problem, which is of huge importance in engineering, it stops bridges shaking and falling down and stuff like that, is wasting time and effort. And I discovered that by reading the journal. As I recall, it was written in German with a Latin preface. The book was in the library, sort of whatever its date was, a few centuries ago, and it was covered in dust. And I actually sneezed when I opened this thing, and I took it to the librarian, who was utterly gobsmacked when I wanted to borrow it. And she put a sticker in the front page so I could borrow it. I was the first person in centuries to take that volume out of the library.
Well, that seems a typical natural human inclination to try to make things more complicated than they really are. You're saying that things don't have to be that complicated.
You can make them simpler. And what tends to happen in science, for example in arithmetic, you can't divide by zero. Oh, it's a problem. Let's work around. Let's make more and more complicated theories to work around. If you reanalyze it and decide that you can divide by zero, all that complexity disappears. All those techniques are still valid and useful, it's just that you can solve problems a different way.
Now, I'm quite interested in what developments within the field of computing, sort of mathematics, that you yourself think have been the most sort of exciting or most important that have occurred over the last few years.
I think the most tremendous opportunity is theorem provers. So these do mathematics, they check that your mathematics is correct. To an extent they can solve problems for you, but they usually need guidance. And what's great about that is it makes sure that your work is correct and checked. Over actually the decades, the theorem provers have got better, and they're now getting to a position where you don't have to be a mathematician to drive them. You can be a computer scientist. When that pushes down into anybody in the world can do it, school children can do it, you'll be liberating mathematical ability in the population. Essentially, you'll get rid of all the slips and silly mistakes. I'm dyslexic. I once wrote down a proof back to front. The editors caught it. That limits my capacity to solve mathematical problems. When I work with a theorem prover, then I can do a much better job. Things like Mathematica are fairly well known. The second thing that does is it creates potentially, well it already creates, but potentially you have a machine repository of all of the mathematical knowledge in the world, which is checked and its domains of consistency are known. So instead of mathematics existing in journals, it could exist in a computer system and would be there to solve practical problems and be there to drive research itself and prove it consistent. Did you know that 80% of mathematics papers in journals have errors in them? Everything from teeny-weeny little errors to absolutely catastrophic things. The amazing thing is that 20% are completely right, and that's very high. I don't know what the equivalent is for computing. In my experience, I guess less than 1% are completely correct. Just about every computing paper I've read has a fault in it. Not so in mathematics. 20%, it appears, is absolutely right. And you could drive that percentage up to 90-95% if you used theorem provers to write the material, and you could then submit it to a journal. You say, here's the machine proof, you recognise what that does for you, and then the question is about translating that machine proof into ordinary mathematics so it's more accessible to mathematicians. As the community adopts these techniques, you won't need that translation step. People will accept the machine proofs.
Now, as a researcher and lecturer, what would you say is the sort of hardest, most challenging part of your job? What's the most rewarding?
The most rewarding is when you you help a student think for themselves. And schools, especially these days with all the bureaucracy going on, is very, very much spoon-feeding students. And the same sort of pressure is on universities with the research excellence framework and so on, things that stifle innovation and stifle teaching. Did you know that I have to write my exams before I give the course? This means I'm completely limited on a new course. I have to guess what I'm going to be able to teach in the time available and stick to it. In the old days, we didn't have to do that. I could take on a new course, adapt the material to suit the students, and we'd make progress wherever the students wanted. I can't do that now. I have to give out notes in advance for the whole course. All of this is providing so-called excellence. It's ensuring minimum standards in teaching. The problem with it is that it enforces minimum standards. You can't do the extra. So the biggest frustration in my work is that the administration prevents me from doing my job. And it's the same for the tens of thousands of university lecturers everywhere across the system. It's a real problem. The joy, correspondingly, is when you get a student and open their eyes to the things they can do themselves, regardless of what anyone says. I have at the moment a student who wants to adapt his laptop to be a server. And of course, it will run too hot. So he's worked out that he can buy a very small aquarium, fill it with mineral oil to conduct the heat, and he's talking about putting all the connectors together so that the machine will run in this environment. So my students are building their own machines. I set a task once, everybody does it. How fast can you sort data? And the student was telling me answers that were orders of magnitude too fast. And I said, look, how are you doing this? It's not possible that you're doing this on the machine in front of you. He said, I know, I built my own 6-processor machine. So during the time of my course, which was 10 weeks, he had built his own architecture to solve a problem I'd set. That's the kind of thinking, creativity, resilience you want in pupils. And that's what's stifled by the bureaucracy.
I'm just looking ahead now. I mean, what developments in your field can you see being made by yourself and others over the coming years that would affect the sort of the IT industry on a wider scale?
Yeah, there are several themes that are playing out at the moment. One is to do with human-computer interaction, making machines easier to use, and software now is getting really easily, especially driven by apps on mobile phones. The issue is your mobile phone is very, very small, the screen's small, the interaction has to be straightforward and simple and very focused. The difference between an app and a web page is that the web page has loads of information on it and you can find your way. The app drives you down the solution to whatever you want. Brilliant things like finding your way around town or knowing when the buses are running or whatever it may be, looking up films at the theatre. Very, very life-focused stuff. So what I expect is that software will become easier to use. It'll be much more directed to the things that people want. And another influence is social media. There really are developing new ways of people interacting person to person and the machine making it possible. So for example, I'm working with a local school that's putting on a trip to NASA, and they want to speak to space scientists. Here in Reading there aren't that many space scientists around. I could go to Guildford, but I happen not to. I work in Second Life, and there I have met NASA scientists and space scientists. So dressed up in my funny gear, I go off into Second Life and interact with these people and get support for a local school. Brilliant, motivational possibility. The plan is that we should have a school in Florida close to the Kennedy Space Center that works with a school close to Reading, that they work together on computing and physics and mathematics projects, and then the UK school visits the US one and goes to the Kennedy Space Center to see NASA. Possibility of a physical transfer of pupils the other way. All of that is made possible because I've got a funny avatar in Second Life, and so do a whole bunch of NASA scientists.
We're here interviewing on behalf of BCS. So I know that you do quite a lot of work for BCS.
Yeah.
Can you tell us a little bit more about that, and also what your own thoughts on how BCS can help the wider IT community?
Okay, I've done a number of things for BCS. I was chair of the Berkshire branch for 3 years. Very active branch, and the guys are all set up and doing a great job in my absence. Well done, guys. I also engage with BCS Elite, and I'm organising events in the Thames Valley that's aimed at CEOs, CIOs or CTOs of companies. I'm working with the Institute of Directors, and the plan is that we present events that are of interest to the higher levels of the business community, regardless of whether or not they're in computing companies. And that gives an opportunity to spread the word about BCS and the technologies it provides to a community wider than its own membership. The BCS membership is very well informed. It's a small part of the total computing industry. We could make it bigger, and the way I hope to help do that is by putting on events at a high level that are of interest to everyone at the high levels of business. What's really tremendously helpful in that is having access to all of the BCS specialist groups. So there are a number of the specialist groups that are of relevance to business and commerce, and they'll soon be contacting those people asking for speakers for the Thames Valley BCS Elite events.